Hello and welcome everyone to the live stream, the late show with myself, Stefan Burns, Saturday night live, and it's going to be Sunday morning soon actually with where I am. So hi and welcome. I'm your host Stefan Burns, geophysicist, geologist, space weatherman, cosmic bro, just someone interested in what's happening here on Earth and in our solar system energetically. So we look at things from a variety of viewpoints, open to basically everything. Just want to understand what's actually happening, not limit ourselves. And so we've been talking a lot about what's been happening with the sun as we do on this channel. And well, we've had four big, gigantic coronal mass ejections launched from the far side. And if those, to put this into context, we'll explain everything. We just had our first magnitude 6 earthquake in more than a week. We have 3I Atlas, that interstellar object flying on the far side of the sun. We have a massive hurricane forming in the Caribbean, about to strike Jamaica, likely at Category 5, Category 4. Ton happening. But if those 4 coronal mass ejections had launched out and hit the Earth, it would have been a very long duration geomagnetic storm. It would have been likely a severe to an extreme storm, so a G4, G5. Probably would have set some records. Not Carrington level, but you have 4 back-to-back over 4 days, because each CME, coronal mass ejection, we call them CMEs, but you can call them a bunch of things, waves of plasma, blobs of plasma, it's really what they are, just the fourth state of matter, super vibrational, highly energized, the sun is full of it, right, blasting it off. Huge explosions basically occurring on the sun, like massive explosions. You put the Earth where that explosion took place and the Earth would just boom, it'd be gone. Thankfully, we're at our 1 astronomical unit distance away from the sun. But they've been happening every single day now for 4 days, about 24 hours in between. So it would have been get hit with the big one. The first one was the biggest. We'll check out the footage. Get hit with that one. 24 hours later, boom, another one comes in. 24 hours later, boom, another one comes in. We've had 4 now. We were forecasting this sort of solar activity nearly 3 months ago, back in late July, to occur during this time window here, late October. So pretty wild that you can look at certain forces and factors and forecast out solar activity that far in advance. This is not something that the mainstream is doing. You won't find any space weather forecasts out on official channels like NOAA or NASA or anything months in advance like this. They'll do longer, like, hey, we're in a solar maximum phase. But you kind of have to go to cutting edge stuff to get these sort of up to date forecasts and these long range forecasts like we do on the channel. We've also done earthquake forecasts that have been spot on. 3 days before that mega quake, we forecasted an 8.5 or greater to hit Kamchatka. So if you're new here, welcome. This is what our sun looks like right now. This is the past 48 hours or so, maybe 48 to 72. I think it's just 48 hours. And so this is the Earth-facing side of the sun, right? Just like there is a sunlit side and a dark side on Earth, right? You know, we go through our 24 hours. We also only see one side of the sun at any given moment because we're rotating around. The sun very slowly rotates. About takes 28 days for it to do a rotation. It's actually a little slower in the polar regions, but in this equatorial zone, about 28 days. And so we're also orbiting around the sun like this. But in general, this is Earth facing. You see how slowly it's rotating. And then there's the other side of the sun. So if things are happening on the other side of the sun, it doesn't mean it's not affecting us energetically, but it's not as direct. For example, that first big explosion triggered what's known as a proton storm here on Earth. It did not hit the S1 level, so it was not a strong radiation storm, but it did elevate these highly energetic protons and electrons and ions coming in. So, and people have been feeling this. Like the moment that storm happened, my dad was like, oh, my stomach. And he's got like an iron stomach. It's like, that's weird. So there's like effects that you can have. I've been having like a headache for the past 2 days because there's been so many explosions. Some people are very sensitive, others are less sensitive, but they're becoming more aware of these connections. It also can give you like a ton of energy and stuff. But 4 big explosions on the far side, all blasting off that direction. In fact, all of them have been blasting off in the direction of that interstellar object 3I Atlas. That is what we use primarily to forecast this activity starting in and around the 21st of October, because that was when we had the perfect alignment of the Earth, the moon, it was a new moon, the sun, 3I Atlas. Because of that alignment, I was like, well, we're probably going to have some enhanced solar activity, because we see when comets fly by the sun pretty close, especially bigger ones, we often see enhanced solar activity, more explosions, more flares, more coronal mass ejections. You can go back to last October in 2024 and check out Shan. That thing flew right across in front of the Earth, and we had tons of solar storms launched towards Earth. We had a G5 minus G4 geomagnetic storm that really came in on the 10th. Shan flew in just a few days before that, right in front of the sun and the Earth. You can look at superior conjunctions of Mercury, the planet closest to the sun. When it's on the far side of the sun, exactly opposite the Earth, we often see enhanced solar activity at that time because of some sort of like electric circuit dynamic, it seems. You know, we have these Birkeland currents that reach out from the sun and connect down to Mercury, and actually the circuit connects down through the crust and into the core of the planet, we hypothesize. And there's other examples. We had a big Cazimi sequence in 2024 where we had Jupiter, Uranus, Mercury, and Venus all on the far side of the sun reach those exact alignments opposite of the Earth. And right around that time frame is when we had the G5 Gannon storm, also known as the Mother's Day storm, because that was from May 10th to the 12th of 2024. The biggest geomagnetic storm that we've had in this solar maximum, solar cycle 25, which has been much stronger than expected. So we see this clustering, and that's just a few examples, but we see this clustering of intense solar activity when you have specific alignments of things near the sun, and especially when these are things that normally aren't there. The planets are normally around the sun, of course, but when they do come into alignments, we see enhanced activity with solar storms, geomagnetic activity, and sometimes even earthquakes. But when you have comets fly in, way from who knows where, and it has a 100,000 year period, well, that's like a new, unique electromagnetic dynamic that's at play. And so it changes the electric field gradient and can create these short circuits, and we don't know exactly 100% the science. The mainstream is way behind on this. That's it's just what it is. As they are in most things, actually. If you research into most fields, you're like, ooh, they're kind of like 20 years behind at least. Like the science of fasting and a whole bunch of things. I mean, there's so many things. Regardless, once you look at where the solar activity clusters, you notice that there's often these alignments or comets nearby. So we have these really big sunspots rotating soon to the Earth-facing side of the sun. And if they continue to be as active as they have been, well, then we could have some really big impacts. And that has an effect on technology. Now, we haven't had any solar storm impacts that have triggered crazy technological changes or collapses or things of that nature really yet. The best example I can give you would be 1989, the power outage in Quebec. We had a G5 storm impact, and that caused there to be a power outage for the entire city. But the biggest storm was the Carrington event in 1859. And that caused telegraph lines to melt, and some stations exploded, and people were even communicating over the telegraphs without their batteries. They disconnected them, and the electric currents flowing on these wires being induced by the geomagnetic storm were so strong that they could operate their telegraphs normally. But nowadays, we are so technologically dependent, and we have so much technology that if we get something really big to come in, we don't know what's going to happen. We really don't know what's going to happen. So here we have our far side view of sunspots based off of helioseismic data. So this is our Earth-facing side. We have a magnetogram, so we can see the magnetic field. But on the far side, we use helioseismic, and these big black regions there are these sunspots. Now, this is a low-resolution look. Keep that in mind, okay? But we saw what they looked like when they rotated off of Earth-facing, because they grew to large size during their last rotation through Earth facing, they weren't there. Then they popped out of nowhere and they got quite big. And then they got very active. 4 coronal mass ejections down the road. We'll look at that next. But they are soon to be back to Earth facing. So we have a lot that's happening right now. Let's look at our last 7 days of coronagraph imagery right here. And this starts really on the 21st with the superior conjunction of 3i Atlas, which is barely visible basically here. You have to really zoom in, punch in to see it in any detail. But look at how we start getting these plasma ejections, okay? Then we're gonna, here's our new moon, right? So this is our alignment right here. It's doing this weird orbit because of this satellite being in geosynchronous orbit, but there is the first big, gigantic coronal mass ejection. That would have been a big G4 or even G5 impact, high velocity. There's the second one, also from the far side. All these again are on the far side. And you notice that they're about 24 hours apart. Here's the third one, boom shakalaka, like right out. Again, this is basically aimed towards Venus and 3i Atlas on the far side. And then we get our most recent fourth one coming up right here. So 4 in a row now. When there are, yeah, right. Sorry, it was on the 25th that occurred. There's our fourth one right there. So when you get 1 or 2, you're like, okay, maybe it's just like one or, it's a coincidence or something like that. When you start to get to 3 things, my philosophy is that you get 3 things in a row, you got something, okay? And then you start to get 4 or 5 in a row, then you definitely have something. So this is no coincidence that we've had 4 big solar storms launch out over the past 4 to 5 days. And what this fourth one is showing us is that those sunspots have yet to die down. That for sure was the biggest one of the 4. But we see these other 3, they're still all quite large. And maybe things cool off, but then they like recharge and start blasting the Earth. We don't know. At least it's a heightened probability right now. That's the thing. As it relates to space weather, as it relates to earthquakes, we have to go off of percentages and probabilities and look at what's happening, the prior activity, and assign our base cases and our best assessment of what could happen, what's most likely. So if these sunspots weren't on the sun, our probability of there being a Carrington event is exceedingly low, basically non-existent. But when you got some big sunspots on the sun and they're pumping out huge solar storms and they show no signs of letting up, well, the probability of there being a big impact goes way up. So that's just, it's just simple stuff. It's not complicated. So here we have some data on the Carrington event, 1859. If you've never heard of it, it was a massive solar storm impact, one of the biggest in the past 200 years, probably the biggest in the past 200 years, though it is hard to say because we don't have that much data on it. If this was to hit us now, the amount of data that we would receive would be incredible. But nowadays, we don't have that much data. So the Sun-Earth transit time of that coronal mass ejection was about 17 to 18 hours. Very, very fast. This is very high velocity. Normally, it takes a solar storm 2 to 4 days. So this was under 24 hours. And the geomagnetically induced currents were so strong that some telegraph stations were able to operate without electricity, as I mentioned, and a few even caught fire. The DST minimum for this is a way to measure the strength of a geomagnetic storm. And we'll see how this is relevant with the 3 other examples we're going to go through, was -800 to -1,750 nanotesla. That's the estimated DST, which is huge, really powerful. Now we can even go a step beyond a Carrington event. And we have what are known as Miyake events. And we don't exactly know what they're from, whether they're from the sun, whether they're cosmic, maybe it's even some sort of Earth-derived energetic event. We really don't know. All we know is that we see the radioisotopes for these Miyake that are about 10 times stronger than Carrington events in terms of the total energy. You can measure that in ergs or joules. I mean, there's a variety of ways to measure energy, but they typically measure them in joules or ergs. And we see these huge spikes in carbon-14 isotopes, also beryllium-10. And so the Carrington event is a big thing that if it was to happen now could cause perhaps some reset or collapse of technology. Imagine what a Miyake event would do. This is one of the stronger ones that was found. 774, 775. We've had more recent ones too. I think like 1078 is a Miyake event. There's also, I believe it's maybe 1279, something like that. You also can go further back in time. We seem to get them, they seem to cluster in time around like a few hundred years. And then there seems to be kind of 1,000 years or so, or 2,000, 3,000 years in between. But we also have not identified them yet. We observe these isotope spikes, specifically carbon-14 in tree rings. And the most likely cause of these Miyake events is we think it's from a mega solar storm impact launched from what's known as a super flare, which again is about 10 times stronger than the type of solar flare that can create a Carrington event. So we're talking about like an X400 flare, something like that. You have different designations for solar flares, and the two top categories are M and then X. And like a 1.0 X class flare, that's a strong solar flare. You get like a 10, like a 10 X flare, that's a really big solar flare. We haven't had anything yet in the double digits for this solar cycle. We've had at most, I believe it's a 9, but maybe it was a 7. But we've had some really strong X flares, but no double digits this cycle. They expect that the Carrington event solar flare was even up to perhaps 60, 70, 80, 100 on the X flare rating. So this is order of magnitude jumps. When you go from 1 to 10, that's an order of magnitude jump, a 10x increase. Really big stuff. But we have also dodged some other bullets. The Great Storm of February 1872 reached Earth in just over 1 day, so a little bit more than that. Estimated minimum DST was negative 832 nanotesla, to put that into context of the Carrington event. Intense earth currents in regions like Bombay, India, right, which is pretty far south. So they measure really strong telluric currents there. That is what causes these technological problems. Basically, you have all this energy coming in from the sun, and it hits Earth's magnetic field, and then it funnels down into the ionosphere, the uppermost atmosphere of the Earth, going from about 50 to 1,000 kilometers. The strongest region of the ionosphere is the F2 layer, and that's about 300 kilometers up, okay? So you get these really powerful electric currents flowing there. And at night, if it's at nighttime, you'll actually see the aurora, right? You'll see the plasma moving across in the atmosphere and also lower down. These are extremely powerful electric currents. During the day, you don't see them because they're invisible during the day, but they shine at night. Well, these electric currents, they induce electric currents in Earth's surface, because an electric current creates a magnetic field that is orthogonal or perpendicular to that electric current. And then that magnetic field and those fluctuations will also then induce an electric current orthogonal and perpendicular to it via the right-hand rule. So you have these strong electric currents up here. Now you get these intense magnetic fluctuations. That's the geomagnetic storm, right? And these can be swings 1,000, 2,000 nanotesla in strength if it's really powerful, even 3,000 plus. For the Carrington, it may have been more. Huge swings in the magnetic field, much more than normal. This connects to our circadian rhythm, our biology, cellular voltage gradients, and more. That's why people can feel like, dog shit during a geomagnetic storm, especially a strong one. It can really hit you. And things like bacteria are magnetoreceptive, and they really interact with the magnetic field. Birds are like, they have no idea where to go if they're migrating because the magnetic field's going crazy. They use that for navigation. Whales and sea turtles and stuff. I mean, it affects a lot of creatures on the planet, including us. We are not like blind or immune or numb to this stuff. But then those magnetic fluctuations, again, through the laws of electromagnetism, magnetic field generates an electric current. So now you get these electric currents in anything that's conductive near the surface. So normally, before advent of technology or copper wires or any of that stuff, it's just going to be flowing through the ground surface. In some areas, let's say they're more rich in like iron-bearing minerals or ore deposits, they're going to have stronger electric currents, and then they're also going to be stronger where these energy fields are stronger, which is the polar cusp regions in the Arctic and Antarctic circles, but they'll bleed down. So again, this one, strong earth currents in Bombay. Like, that's really far south. There's 1 billion plus people in India. Imagine like India goes offline. Woohoo! China goes off, like whatever, right? So then now, if you have these highly conductive structures, which are these long transmission lines, that is how you get a power outage. If they're strong enough, the voltage difference across that 1,000 kilometer line or something like that will be too big for the system to handle, and it just causes it to short circuit, explode, transformers gone. If you get like 500 transformers to blow out, the whole power grid is shut down, especially here in the States, because we sent a lot of our critical infrastructure to Ukraine to help them rebuild from all the bombing done by the Russians. And so maybe we've rebuilt our stockpiles, that I don't know. But certainly at one point, we basically had nothing on hand in the event of some sort of disaster. And we did this during the solar maximum. That was stronger than expected. So, you know, I've been to Ukraine before and after the war, like during the war, like my heart bleeds for them. But that probably wasn't the smartest thing to do, to send our own critical backup. But regardless, you also had the Great Storm of May 1921. The currents on the New York rail lines got so strong, they said that it could kill a man. Like it could zap and kill him. This is like 700 volts, 800 volts, 900 volts. The transit time on this one, 20 to 27 hours. Minimum DST reached negative 900 nanotesla or greater. And the geoelectric field in high latitude regions reached 10 volts per kilometer, which is insane, right? You stretch that out, it's a really big buildup, okay? Geomagnetically induced currents up to 1,000 volts. That's your wall runs at 120 in the US and 220 in Europe. So, you know, you don't want to get zapped by that. Don't stick a fork in there, right? 1,000 volts is much, much, much higher. The lucky storm, I call it, this is not what it's officially known as. There's no official name for this, but I call it this. This is August 1972. A huge coronal mass ejection launched from the sun, hit Earth 15 hours faster than the Carrington event, okay? 2,800 kilometers per second. What happened was that it did not have a magnetic field structure that was conducive to connecting to Earth's magnetic field. That's what made the Carrington event so special. It was fast, it was strong, it connected to Earth's magnetic field, it had all the characteristics needed to be an epic solar storm impact. Whereas all these, like this one was a little slower, right? And some of them, this one probably just wasn't from as big of a solar storm, explosion solar storm. This one was very fast, it was big, but it didn't have the magnetic field structure. So we didn't get a big storm from it. The DST only went down to negative 125, which is actually insane. It only went that little because of the strong positive BZ component. If you know space weather, you know what I'm talking about. But there was a report that came out showing that there was a sudden detonation of large numbers of magnetically influenced sea mines in North Vietnam during this impact. They had just put them out a few months prior, so they weren't faulty as far as we know. And then right when that impact came in, within that time window, boom, 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 boom. You're getting these sea mines exploding in the ocean off the coast of Vietnam. And then you get geoelectric fields exceeding 7 volts per kilometer in places like Iowa and Illinois. Imagine Chicago going offline. Imagine New York going offline. Imagine Seattle going offline, right? This wouldn't just be Fairbanks or Ottawa or, I mean, Toronto and Quebec are big. Like, we don't want any of those places to have any problems. But you get bigger population centers as you go further south, undoubtedly. And so, like India right there. So these are three other storms that are fairly comparable to the Carrington event of 1859. We also had the lucky miss in 2012, where we had a massive coronal mass ejection launch out that missed us by just 7 days. And they say that was likely Carrington level. So here we see a visualization of Earth's geomagnetic field before and then during the Carrington impact. And we don't know how accurate this is because, again, we really don't have that much data on this, like good data nowadays, like magnetic field measurements and, you know, satellite readings and stuff. But we see Earth's magnetic field, the magnetopause. Look at this solar storm come in at super high velocity and how that pushes the magnetopause super close to Earth. That means that you get a ton of this solar plasma interacting with the ionosphere and creating these strong electric currents, strong geomagnetic field swings, strong induced currents, and that's what gives you the telegraph lines exploding and stuff, okay? It's just basically a sudden collapse of Earth's magnetic field under the pressure of a solar storm, which eventually abates, and then Earth's magnetic field isn't like permanently damaged. It's just under a tremendous amount of pressure that finally then releases and returns back to normal. But there's going to be long-term changes after this. From the Mother's Day storm in 2024, the Gannon storm as they call it, May 10th to the 12th, that changes the structure of the radiation belts. They track that out, and for like months afterwards, the radiation belts surrounding our planet, these zones of high energy flux, they were significantly different. We had a 4-belt structure. Normally we have 2. So big difference. And we can see another visualization here for the Carrington event, or no, sorry, for the storm that occurred in 2012. So here we have this visualization, and we see stereo A. Stereo A got hit dead on, okay? So if Earth was stereo A, it would have been a big deal. Look at all the activity that was occurring before the big event occurred, right? It wasn't isolated. There was other stuff occurring, and then we got that gigantic coronal mass ejection. Seems awful similar to what's happening right now. You have this lead up of activity, and then you get the big event. So we've had 4 of those coronal mass ejections. The first one was so far the biggest, but was that like foreshock activity, you could say, like with an earthquake? Was that all preliminary activity leading up to something bigger? Like this, 1, 2, 3. You're like, oh, that was a big one, right? And then all of a sudden, like, you know, that occurs. That's very possible. It's possible. So if we did have a big technological reset in a significant way, that could really alter the course of history. So it's very possible. Let's look at our satellites, because we have a ton of satellites, like tons and tons of them. So let's see. Let's look at them. I have a web platform up here to check this out. And I don't know how to take this bottom thing has never popped up before for me, so I don't know what the deal is with that. Oh, here we go. So here we have all the satellites that are surrounding the Earth. Well, maybe not all of them, but I think they've done a pretty good job putting them all in. It's really quite wild. So we have different zones. For example, this whole ring structure there, that's geostationary satellites. They're all at 5.6 Earth radii. And then you also notice that there's just a diffuse cloud of satellites, and some of them are inactive all around. You even have some other orbits. So like see this one right there, that ring. That's also geostationary, but slightly offset, more in line with like the tilt angle. And then you have low Earth orbit, and then you have, that's like LEO satellites, low Earth orbit. And then you also have satellites are a little higher up. So you see a lot of Starlink satellites in here, and just in general, a tremendous amount of our infrastructure now is actually in space, like a huge amount. So the thing is, they also experience massive amounts of charging when you get a big solar storm impact. And we've seen with Starlink that these satellites, when we get a big solar storm impact and geomagnetic storm, often they may short circuit from deep dielectric charging. That's what it's called, deep dielectric charging, where you have these strong voltage potentials build up in the circuitry that eventually arc and cause the tech to basically fail, right? A short circuit. It's a, think about the word short circuit. Maybe not everyone's like realizes what that means. You have a electric circuit, a flow of current, and then all of a sudden that gets cut in half or something because there's now a new, more conductive pathway. So it's shorting, it's a short, making it smaller and creating some circuit that's not, the technology doesn't want, because it needs specific circuits to run, right? It's very precisely planned. But if you get a short circuit, now you can blow things out because they're not rated for that amount of voltage or whatever. So that's what a short, like, think about the word itself. Maybe this is redundant, but I don't think it is. I think sometimes we learn words and don't even think about what they actually mean. Short circuit. So what happens is you get this deep dielectric charging. It can short circuit something, cause it to fail. And then also you get an increase in drag because all these new solar particles are now close into the Earth, increasing the drag on these satellites. And that can cause them to go below their operational orbit and then do a unplanned re-entry and burn up in the atmosphere. And we have about like 2, 3, 5 Starlinks every single day now being burned up by the atmosphere. They're just putting out more than are going down, basically. So that is like the new reality that we live in, where there's space junk raining down upon us. And often it gets to the ground. Like there are whole pieces and chunks and massive things of metal that can go down. Like this eventually will hit people. It's just a matter of time. So you have those two forces also interacting to cause satellite failures. And like telecommunications now is based on a lot of satellite stuff, a lot of military tech. A lot of our weather tracking is all based off of that. So it's serious stuff. And for example, we're talking about weather tracking. We have Hurricane Melissa right now in the Caribbean. And NOAA has said that this is going to bring very likely catastrophic rainfall, flooding, and landslides to Jamaica. That's their term. Like that's their words in their latest update. Catastrophic. They're not expecting inches, but rather feet of rain in Jamaica. Here's the outline of Jamaica. See that? I've been in Jamaica twice. Wonderful place. I love Jamaica. The people there are so nice. Just really good, spirited people. So this is really unfortunate. They don't get too many landfalls like this. You can count them on one hand effectively. And this may make landfall and hover over Jamaica for days at like a Category 5 level. Right now it's estimated to be Category 4, Category 5 when it goes this way. This is the estimated path for Melissa. But it was a huge tropical storm that finally has increased with its vorticity and formed an eye wall. Category 2 right now, expected to be Category 3 actually just within like an hour or two from right now. And then this is the expected path. And they expect it to kind of basically hover over Jamaica for like 2-3 days. And because the water is so warm here and also warm at depth, it's just feeding this monster. And if Hurricane Melissa does get to Category 5, that means that 2025 will be the second year with the most Category 5 hurricanes on record. Last time was 2005. So while the United States didn't get really any hurricane action this year, if this does get to Category 5, it was still a record-setting year for hurricanes, effectively, in terms of maximum Category 5 being reached across multiple hurricanes. So really wild stuff. So we could lose access to critical infrastructure like that, tracking these things, right? This is from the GOES satellites. They're basically stuck on a positional vector with the Earth. So as the Earth rotates, they also orbit with them, with that point, so they can track very specific spots on the globe across, for example, this is channel 13, infrared. This is the GOES 19 satellite, so on and so forth. There's a whole bunch of stuff you could learn here. Here we see the track of Hurricane Melissa, and we can see how it's just been basically hovering as a tropical storm and finally started to get some shear. There's the Category 1 level here. Now it's Category 3. According to this, it's Category 3 now. So it looks like it just strengthened to Category 3. It was Category 2, now it's Category 3. We expect it to get to Category 5 right here, and then they're actually showing it make landfall at Category 5. This has been just updated in the past hour since I checked. So that's the latest. You can go to zoom.earth to check this out. Yeah, wild stuff. And we have some space weather coming in. So we can go to our NOAA website and check out the forecast discussion. If you want to ever read this, you go to procs and data. This is linked in the video description. And then you can go to forecast discussion and click that. And they release these every 12 hours. Thankfully, they still have some people working in the space weather department. They're not totally shut down because of the government. But the forecast here, the geomagnetic field is expected to remain at quiet to unsettled levels over the 26th of October as negative polarity coronal hole influences wane. Active levels are likely on the 27th due to the anticipated arrival of the coronal mass ejection that left the sun on the 23rd. G1 conditions with a chance for G2 conditions are likely on the 28th due to the anticipated onset of influence from a positive polarity coronal hole. So they're expecting our geomagnetic conditions to become active from some coronal mass ejections, specifically one impact they're talking about, but there was like a little bit of stuff sent towards the Earth recently. Remember, we've been talking about the far side, but there has been quite a lot happening on the Earth-facing side. So they expect this to hit us in about 24, 36 hours or so, maybe 48 hours. This is coming in right around the 27th universal time, according to the model, but they're often up to 12 or even 24 hours off. Sometimes they're right on. So, space weather forecasting is difficult. We're glad that we have people doing this. We just wish that they were more inclusive of some of these other things that definitely seem to help with long-range forecasting, like planetary alignments and comets and interstellar objects and such, which is what we track on the channel. The universe has different outlets for these things. But in addition to that, we can go back to our big sun here. This is the coronal mass the coronal hole that they're talking about. So we see this large coronal hole here with a section up there as well, and this coronal hole with a plasma filament right there, which is interesting. But this is, I believe, the 15th rotation of this coronal hole. We've had multiple rotations from this coronal hole. I'm honestly starting to lose track now. I believe it's rotation number 15. So this has been on the sun since last October. It's been more than a year now that this coronal hole has been here. And this will be in that geoeffective position around the 28th, 29th. It's just now the 26th, early morning, 12:19 a.m. East Coast time. Based off of this video and where this gets, I think it's a little optimistic to say the 28th. I'd probably more lean to this interacting with Earth on the maybe late 28th, 29th, because it needs to really get to this geoeffective position right about here. But these are also linked to earthquakes. We've been tracking that on the channel. It's actually the main thing that's helped us be accurate in forecasting high magnitude earthquakes. If you don't believe me, you could go back, look through the record. There's quite a bit of stuff there. I know it's a little daunting of a task, but maybe a community member can make a compilation video of all the forecasts and then, the actual event. That'd be a cool thing. If you do that, post that to the community and let me know, or do a shout out on Twitter or something. But these are connected to earthquakes. That's what it seems. They're at least highly correlated. So that's the thing. You can't deny the correlations between these and earthquakes. Like you can't deny the correlations. What you can debate is whether it's just a correlation, just random, or whether it's causal. And my thought is well, can't really get more causal than the sun, right? This isn't this isn't movies that Ben Affleck to start in compared to earthquakes or something stupid like that. Like, the sun is the main engine of energy and life in our solar system, and without the sun, the Earth would be a cold, dark place. The solar radiation is what fundamentally gives the Earth energy, other than just like a bit of energy from radionucleotide breakdown in the core and stuff, right? Like uranium and plutonium, right? These isotopes. So you have to kind of go back, like, how is the Earth getting energy? Oh, it's from the thing that makes up 99.86% of the mass of the solar system, this massive plasma and whatever engine. So yeah, like, there's mechanisms that explain how heliophysics impacts geophysics. They are not separate. Everything is connected together. It's just sometimes a little bit more than some people can wrap their brains around. But they're all connected together. So it makes sense that the sun would have an influence on the Earth and on its geology across time. Human time scales, longer time scales. So we could very well be having some big earthquakes soon. Actually, I think that's likely. We've been in a bit of an earthquake drought, though that did just kind of change today. We just had a magnitude 6 earthquake. First magnitude 6 in more than a week. Typically, we get them more frequently than that. This is magnitude 6 north of Vanuatu, and then to the southeast of the Solomon Islands. So basically right in between the two, in the Ring of Fire. If we go to our past week of data here, you'll see what I'm talking about. This is the biggest earthquake of the past week, 5.9. Costa Rica is the next biggest earthquake, then some 5.8s. But typically we're getting more than just a magnitude 6. Also, though, we do see this clustering with earthquake activity. So global seismic energy release, of course, if you zoom out far enough, it's going to be flat and homogeneous, right? Everything can average out to, to homogeneous. But when you zoom in, things are not homogeneous. So we can actually go to volcano discovery to look at that. Let's go to volcano discovery. I want to show you just some of the past records of earthquake activity. These websites that give you the pop-up in like the first second, there's a problem with that. Like, come on, guys. You could at least wait 20 seconds for the pop-up. Some websites hit you like 4 times with 4 pop-ups in like the moment it loads. And it's like, did you really think about this? Do you even like visiting your own site? If you don't even like visiting your own site, you have a problem. So, I don't know. People just are thoughtless nowadays. So here we have our earthquake activity past 90 days. See this clustering? Right? We kind of get this clustering of earthquake activity, and then we get these periods where like nothing happens for a while, and then boom, we get a lot happening. These are all points where we went extreme on the activity. So big earthquakes. And we can scroll down. Here we have all of 2025. Again, you can see a clustering very clearly. This is March, end of March and beginning of April, and this right here is the end of July, beginning of August. So very distinct clustering so far this year, 6th strongest year on record, maybe even the 5th, because we've had some big earthquakes other than just the magnitude 8.8 in Kamchatka. But you see last year, 2024, was quite mild compared to some of these other years. Here's 2023, 2022. Look at the clustering, right? Boom, boom, boom. Same here, 2021, clustering right there. So yeah, it's definitely, I mean, look at this. You have basically nothing, and then you get this flurry of earthquakes in 2018. 2 big extreme earthquakes, a bunch of very high Mag 7s and more, and then you get this long duration that follows afterwards, and then it goes into this year. So, this next year, 2019. So, earthquake activity is not homogeneous. Of course, on a long enough time scale, it'll look like that, but you zoom in just and get the daily data, and it's not homogeneous. So, we could very well be in a period of heightened earthquake activity going forward. I think that's likely the case. I've been talking about that for a while. I think 3i Atlas is a factor there. When we had the close approach of Oumuamua in 2017, a day before its perihelion, its closest approach to the sun, we had the biggest earthquake of 2017, a magnitude 8.2 in Mexico. Perihelion of 3i Atlas, which is a lot bigger than Oumuamua, more active, it is on the 29th of October. So we're just days away from it now. And then we have these space weather factors. We have these massive explosions occurring on the far side of the sun. We got a lot happening. So here's our position for 3i Atlas. There's been a lot of fake news going around 3i Atlas. Surprisingly, some bigger names are reposting like AI deepfakes and clearly fake news about Atlas, which is really disappointing because you expect people to be a little bit more precise and accurate with what they're going to share to their audience, but a lot of people are just in it for clicks, I guess. I don't know. We're in it here to see what's happening with the Earth so we can be like aware. I think it's awesome to just study the Earth, the sun, solar system, the cosmos, because I just have a burning curiosity and passion for this. So this is really just fun for me. And then if it helps us to treat each other better and to be more healthy and to understand and expand our consciousness and beyond, right, and hopefully take our society a better direction, hey, it's a win-win. So that's why we're here doing these live streams, making these videos and more, so we can stay up to date, aware, prepared, all the things, and have a good time doing it. So here is 3i Atlas today. And its perihelion is on the 29th. So we go forward right here. There's the 29th. And we see that it will be as close as approach to the sun, 1.36 astronomical units. And then as we go on, we see that Earth and 3i Atlas are actually getting closer together. We never get a super close approach. We see that the closest approach will be on the 19th of December, which is right around solstice, which is ready an energetic portal. But we do get fairly close to 3i Atlas then, but we don't get super close. Whereas Mars had a very close flyby. Venus has a fairly close flyby, and then Jupiter has a very close flyby in March of next year. So this is coming up, and we've already had 4 big coronal mass ejections launch this way. They are hitting 3i Atlas at this moment in time, effectively supercharging it. So that's very interesting. And what it then, it's going into its perihelion as charged up as possible. In deep interstellar space, an interstellar object like that is only going to be receiving like 10 to the negative 7 to 10 to the negative 8 irradiance, watts per square meter for irradiance, which is like light from all the stars and also energy from just the normal background radiation flux. It's going to be very low, 10 to the negative 7 to 10 to the negative 8 watts per square meter of energy. Well, with its perihelion at 1.36 astronomical units, that is calculated to be the solar irradiance at 735 watts per square meter. So just taking into account sunlight, right? Just the normal sunlight that the sun is emitting, it is like 10 orders of magnitude higher or more. It could be 10, 11, 12 orders of magnitude higher than it is in deep interstellar space. We don't know how long it's been in deep interstellar space. Has it been 10,000 years? Has it been 100 million years? Has it been a billion years where it hasn't gone close to a star? We don't know. But it's definitely been in interstellar space for a while at very low temperatures and very low energy flux. Now it's going up 10 times 10. Huge amount. And we have 4 coronal mass ejections that have already impacted. The first 2 have very likely already hit it, and you have 2 more now following up behind. So it's going into its closest approach to the sun, its perihelion supercharged. And we don't exactly know what it's going to do because we've only ever found 3 of these interstellar objects, and we still really don't understand the plasma dynamics of the sun and space and the cosmos. This is all stuff that's recently, just in the historic scale, been thought about, theorized, modeled, equations and stuff of that nature. I mean, you have to go back to Sputnik, right, to get the first satellite. That's not that long ago. I think that was 1957. It hasn't been that long. We don't know anything, guys. Like, we put some people on the moon. A lot of people think maybe we didn't. I'm starting to lean to the fact that we did because it was just an incredible time period back in the 60s. And somehow just like the triumph of human spirit and technology. And we've done a lot of incredible things, but we haven't done anything. Okay, what? You put a few people on the moon a few times? Like, the whole solar system is ready to be explored. And we're failing right now at getting people back to the moon. Like, what? 60, what would it be 70, like 70 years later? What, because going from, let's say, just 1970 to, that's 30, like 55, oh my God, like 55 years? Like, what are we doing? So we know very little. We know very little, and that means that we're in for surprises when some of these things that we don't know manifest into our reality. So we don't know what 3i Atlas is going to do. A lot of people think it's aliens technology. I personally, we have not seen any evidence for that yet. There are some very unusual, bizarre things about it, but we haven't seen any direct evidence of it being an alien craft or technological. We'd have to see changes to its trajectory and its orbit, you could say. We'd have to see very strong changes to that. And that's where some of this misinformation is coming from. People saying it's slowed down 300%. It hasn't done that. We have no evidence of any of these maneuvers or changes or course redirections or little ships flying out of it or whatever. It's just a lot of nonsense out there right now. Doesn't mean it's not possible, though. Its perihelion is when it would perform an Oberth maneuver, which is when it does some sort of assist. It fires up its engines and uses that slingshot effect around the sun to change its orbit. If it's going to do that at all, it'd probably do it to go to Jupiter. That's a whole different video, though, because it's already very closely aligned to reaching Jupiter. So it would only need a very minor Oberth maneuver to redirect to hit Jupiter if it wanted to do that. But as of right now, there's no evidence that it has done any of these things. Doesn't mean it can't, though. So just be very cautious with what you see online. Do your own research and look into things with an open perspective, but skeptical, and don't just read headlines. Follow it down. A lot of these articles, it's like this doctor, this professor said this, and then you look and that person doesn't exist because they're like, oh, we know 99% of people aren't going to actually check it out. So just be, and like I said, there's some big names right now. Like I've been surprised. I'm like, really? Like that person posted that? Like, come on, dude. So I'm not trying to call anyone out here, but there have been some big names, like millions of followers posting just absolute nonsense online about 3i Atlas, which is unfortunate. So anyways, that is the update for you. These big sunspots rotating towards Earth soon could be a big influence. And they could give us some serious solar storms. We've had 4 in a row now. We don't know if that's going to continue. Maybe they kind of burn up and use up all their boom energy, you could say, before they get Earth direct. We have to first get through the coronal mass ejection impact that we have, likely to get us active conditions, and then they expect this to take us to G1 and G2 levels on around the 28th of October. I think we're really... I would say, okay, so here's the other thing. You look at like what's happening. The perihelion of 3i Atlas, supercharged from 4 coronal mass ejections, is occurring on October 29th. That's probably when we're going to have the geomagnetic storm. These things tend to align in time like that. So my forecast is that October 29th is going to be a crazy day energetically. Then we have the full supermoon on November 5th. These big sunspots will be, if they still exist on the sun, will be basically in this section right here, Earth center direct, for that full supermoon. The next 2 weeks looks very wild. So I'll keep you up to date every step of the way. I've been your host, Stefan Burns. Thank you all so much for watching. One final thing to share is that I do have a variety of holistic wellness products and merchandise on my website, earthevolution.com. You can check this out. So it's earthevolution.com/store. And here we see the top sellers for the website. So we actually have some 3i Atlas merch. And people love this shirt. I'm not wearing it right now. In fact, I'm wearing the Cosmos Within shirt, which is the latest merch. But this is fantastic. It's the long sleeve. Has artwork by my father, Lee Burns, on the back. It's very simple. Tons of people commenting saying that they love this shirt on the comments for these videos and also on Twitter and X and Instagram and everything. But there's other things too. We have all our tea blends and our herb coffee in stock. So spirituality is fully in stock. This is awesome. I recommend you pick some up, especially during this time. It helps you connect to your higher spirit. It enhances dream activity, even astral projection, for example. That's something that there are some people that have practiced that, have had those experiences. They said that this helps them. So it's very simple. It's 4 ingredients. Purple lotus flower, you see that guy right there. Mugwort, chamomile, passion flower. They work together great synergistically. Herb coffee is amazing. Helps you to learn new things, get focused. It's just amazing neuropotentiator, and it tastes great. So it can replace your normal coffee. It's half calf because it's half coffee. Really good single origin organic shade grown Peruvian coffee, along with roasted chicory root, roasted dandelion root, and quite a bit of lion's mane mushroom, all organic. Other stuff here too. Here's the shirt that I'm wearing, the Cosmos Within shirt. I'm wearing the midnight blue. The white looks really good too though. Size is small to 4XL. So this is all available on the website. Other tea blends as well, and much more. So definitely check that out. If you appreciate what I'm doing here, all purchases, you know, they help keep things going. And it's also my way of giving back to you guys, because I see how these things affect us energetically and therefore also our health and our wellness. And nowadays, you know, it's hard to find good quality products. These are super high quality. I have the best suppliers, and we make and mix the tea blends ourselves, for example. And so you go to the grocery store and you get some like low quality tea that's just basically the dust from the bottom of a bin, and it's filled with like mycotoxins and dust and mold and stuff. So you don't want to deal with any of that. And then it's super expensive per ounce. This is this whole loose leaf tea. And then the herb coffee is loaded up with lion's mane, which is very expensive, which is why this price is kind of high, but this is the best stuff. And we use really good coffee, like super good coffee. So this is all fairly priced to help you guys out. And people love this, love all these products. So yeah, that is on the website at earthevolution.com/store. Again, I've been your host, Stefan Burns. Thank you all so much for watching. Wishing each and every single one of you well. I'm signing off for tonight, but I wish you a great sun day. I'll see you all very soon. Thanks so much.